Welcome to the FINEMotorPRO news. I'm Peter Larsen from Loudsoft. Here is an example of a motor with extended pole and undercuts. Let's go to the direct FEM flux mode and view this in detail. Here we can do two things: perform an immediate magnetic finite element analysis and also insert various shorting rings and caps. The voice coil is indicated as a white stripe in the scale view at lower left, and we need to insert a bumped backplate for this long voice coil. I will set the bump height to 6 millimeters and maybe choose the 75-degree angle for the bump. We will start the finite element calculation. The FEM calculation is very fast and the flux lines are only shown briefly. The rate curve shown here at the right is the result of the final element calculation. So this is the flux profile taken through the gap. When we say OK, this will be transferred to the main view. The flux profile motor with bump has now been applied, and we see the BL over X, also called the BLX curve, in this window. The green part is for BL within 82% of maximum and guarantees very low intermodulation distortion. If we zoom out, we can see that the whole curve is turning yellow here when BL is going down to 70%, which will be acceptable for normal loudspeakers. But the red area is no-go for less than 50%. We also have an offset, voice coil offset of around 0.1 millimeter, which will give us a very nice and perfect BLX curve. As a start, I will calculate a number of voice coil induction LEX curves through the air gap. The calculated LEX curve shown at right has a maximum at left where the voice coil is down in the magnet system, and then it is decreasing when the voice coil is going up. This is just as expected. So let us try inserting some shorting rings. We have several options for inserting shorting rings. We can try a pole ring, which is inside the voice coil. We can have a pole cap, which is in the air gap. We can have a magnet ID ring, and we can even have a top ring. Right now, we would go for a ring below the air gap because that is where LEX is highest. We recalculate LEX with the pole ring, just like before. Since LEX is higher for positive X, we may consider inserting another ring above the air gap, and this is called a top ring. So we will try that. The new violet curve shows further reduction of LEX with the top ring, and the curve is now almost flat. This result has been achieved without a pole cap, which requires a larger air gap, causing lower BL and SPL. We can freely choose the material for all the rings, and for example, we could have the lower ring in aluminum and the top ring in electrolytic copper, maybe. We can also increase the height of this ring so we can balance everything out. This is a special example of a neodymium motor using 2 rings and 1 cap. These are even made in different materials: copper, aluminum, and electrolytic copper, which is very pure. And the resulting LEX curve is completely flat. So this is a good example of the ideal solution. Let us take a look at the voice coil which can be made with very special windings. So we open the voice coil dialog. If we pick edge wound wire in one layer, we can actually choose bifilar or twin windings. And in this case, we can have one layer inside and another layer outside of the voice coil former. We can choose this exactly as we want. This is very effective for high power loudspeakers. We can also choose flat wire, like here, where the wires are flat along the voice coil former. This may be even more effective. The recommended backplate thickness is actually shown as minimum 5.8 millimeters, but if we want to change it, we can open the motor parts dialog. Here we can specify the baseplate thickness. So if we, for example, choose 5 millimeters, we can see that the loss is only 0.06 dB, which may be acceptable. This is the end of the FINEMotor news. Take a look at lovesoft.com with the fine circle of software where all works together. For example, you can import FM3 files from FINEMotor into FINEBOX and FINECone. Thank you for listening.